Hi everyone, thank you for being here. I'm Xiao, and I'll be presenting our paper titled Malicious LLM-Based Conversational AI Makes Users Reveal Personal Information. This is joint work with Juan Carlos, Dr. William Seymour, and is supervised by Professor Jose Suk. This research explores a new and emerging threat vector, conversational AI agents, or CAIs, that are intentionally designed to extract personal information from users. We analyze how subtle prompt engineering can turn these agents into manipulative tools and how users react to them. The rise of larger models has democratized the creation of CAIs. Anyone with basic prompting skills can now deploy agents that appear helpful, friendly, and engaging, yet potentially deceptive. To put this into perspective, OpenAI's GPT store alone has over 3 million user-created CAIs. The GPT store works a lot like an app store, but instead of apps, it hosts AI agents built on top of ChatGPT. The key thing to understand is that anyone can create one. All it takes is writing a system prompt that defines how the AI should behave. For example, you could tell it to summarize YouTube videos, act like a language tutor, or even roleplay as a character. No coding, no technical skills required. Once that system prompt is saved, the CAI can be instantly published to the GPT store, where it becomes accessible to millions of users. This raises serious concerns. What if some of these CAIs are malicious? Could they be intentionally designed to harvest sensitive data from unsuspecting users? Now, prior research has shown that users often share private information with benign CAIs, particularly when they found the interaction helpful or enjoyable. In analysis of user conversations with ChatGPT, disclosures have included names, doctor's information, and even sensitive details such as medical diagnosis. But our question is more pointed. Can malicious CAIs be engineered to elicit more personal information than benign ones? And if so, how do users perceive these agents? Do they recognize the risk, or do they fall into the trap? This led us to our core research goal, to examine whether specific prompting strategies can be used to design malicious CAIs that outperform benign ones in eliciting personal information, and how users respond to them. To do this, we developed a total of 12 CAIs by combining 3 larger models and 4 prompting strategies. The larger models included Llama 3 8B and Llama 3 70B, which allowed us to explore how model size might influence user interaction and disclosure. We also included Mistral 7B, enabling comparison not only across sizes but also across different model architectures. Each large model was paired with one of our 4 prompting strategies. First, we have benign CAI, which served as our baseline and asked general, non-intrusive questions. We then have direct CAI, which asks for personal data in a straightforward manner. For the user benefit CAI, it first responds to the user queries and then requests personal information. And last, the reciprocal one, which followed a more social approach that show emotional support and also reciprocate to create a sense of mutual trust. We recruited 502 participants and randomly assigned them to one of the 12 CAIs. To make this possible, we built a user interface with Grad.io. After providing consent, participants received a link that opened the interface where they could chat with their assigned CAI. We adopted a mild deception approach. Participants were not told which type of CAI they were interacting with, now that our research focus was on the disclosure of private information. This was done to minimize potential bias in their behavior. Each participant engaged in a free-form conversation with their assigned CAI. They were free to choose any topic, switch topics if they wished, and interact naturally. After the chat, we measured their perception through a post-interaction survey. Our survey was divided into 3 blocks. Block 1 captured perceptions, for example, their perceived privacy risk and trust. whether participants thought the questions were too personal, whether the CAI provided good justification, and whether they shared the same information with commercial agents like ChatGPT. Block 2 focused on behavior, specifically whether their responses were truthful or intentionally incomplete or fake. Block 3 focused on participants' attitudes, including IUIPC score, SA6, and reciprocity orientation. For data analysis, to evaluate personal information disclosure, we used a new extract, a well-established tool for detecting personal information in text. The tool outputs results in JSON format, allowing us to systematically count both the number and types of personal information disclosed in participants' dialogues. To ensure result quality, one of the authors also manually reviewed a random sample of 60 dialogues and compared them with the tool's output. The results in a total of 1,612 single conversation turns. The analysis resulted in a coherence kappa of 0.818, indicating a high level of agreement between the tool and human coders and confirming the reliability of our data extraction. For further analysis, we used the KW test followed by Don's post-hoc comparisons to assess significant differences in the number of personal information disclosures and participants' perceptions across different CAI groups, and a qualitative layer to explore and understand underlying reasons behind the KW test results and to gain deeper insights into participants' experiences and feelings when interacting with the CAIs. So, what did we find? Malicious CAIs were far more successful at eliciting personal information from users compared to benign CAIs. On this chart, you can see the comparison across different categories of sensitive information, things like age, name, job title, nationality, health conditions, and even relationship details. Notice how the benign CAIs barely collect any sensitive data, but in contrast, malicious CAIs consistently extract much higher volumes of personal information. As mentioned earlier, we cross-verified the data disclosed by participants with their prolific records, including demographics and names. This chart shows the amount of fake data disclosed across different CAI groups. Participants were significantly more likely to provide fake data to direct CAI and user benefit CAI, as indicated by the higher bars in orange and red. By contrast, reciprocal CAI elicited much less fake data, at a level comparable to benign CAI. We analyzed participants' perceptions using the post-interaction survey, and here is what we found. Direct CAIs and user benefit CAIs stand out as significantly different from the rest. Though they are quite similar to each other, participants felt these agents asked for too much personal data, even though they acknowledged the request as relevant or justified. By contrast, reciprocal CAIs were perceived much more like benign CAIs. Participants rated them similarly in terms of data relevance, justification, and related factors. What is especially concerning is in the last two panels. Users reported relatively low perceived privacy risks and fairly high perceived trust toward reciprocal CAIs, and many even said they would share the same information with a commercial chatbot. Overall, the reciprocal strategy feels less intrusive, closer to the benign baseline. Reciprocal CAI gathered more personal information than the benign CAI, yet it was able to secure more truthful data, making it the most effective strategy. We also found rich qualitative evidence supporting this result. Participants consistently reported feeling more at ease and comfortable with reciprocal CAIs. They described the follow-up questions as justified and relevant, which created a natural flow and encouraged them to share more personal information, something not observed with the other CAI types. We also examined how larger model architecture might influence the results and found that the larger model elicited more personal information, while the two smaller models did not differ significantly from each other. To summarize, direct and user benefit CAIs are able to elicit more personal information than the benign ones, but participants were more wary of them. Reciprocal CAIs were both effective and trusted, making them the most dangerous. There is a disconnect between perceived privacy risk and actual behavior. People disclose even when they felt uncomfortable. To wrap up, our study points to several key recommendations and directions for future work. First, we need to raise awareness. Users should be educated about the risk of interacting with large model-based chatbots, especially the manipulative strategies the system may use, and also the interdependent risks, like accidentally sharing information about others. Second, we recommend developing protective mechanisms. This includes nudges that remind users about their disclosing, preventive systems that block risky information sharing, and context-aware detection that can recognize when personal data is being revealed inappropriately. Third, it's important to limit inferences. Even when users give partial or fake information, models may still infer sensitive details. More research is needed to better understand and counter these inference risks, and to design privacy-preserving systems. Finally, we highlight the need for auditing and regulation. Larger model applications, especially those distributed through app stores, should be audited for malicious intent, and third-party integrations should be monitored to prevent data misuse. Taken together, these steps are critical to ensure the conversational CAI can be used responsibly without putting user privacy at risk. Thank you for listening.